Hi, hello everyone. In this video, part of our WebGL series, we're actually going to be covering assets and how to load some assets. Also, we're going to change our projection. If you remember, last time I mentioned that our screen space goes from -1 to 1. Here it's 1, here it's -1. But actually now we're going to change it to something else. It's not going to be like that. It's going to be from 0 to 800 because this canvas is 800, but it will be the size of this canvas element. And here it will be 0 actually, and the bottom one will be 600 in my case, but you can resize canvas to whatever you want. So the idea is 2D games are usually like this. They're taking the screen coordinates like this, so it's fairly common. So that's what we're going to be using, and for that we're going to need to learn about orthographic projection. But before that, I wanted to tackle some stuff and maybe refactor stuff a bit because that will help us. But before we start, actually, I already downloaded the assets, and assets you can find them here. They're free to use. So I'll link to these assets in the description video below. Later on in this course, we're going to learn how to actually use the sprite sheet. But for now, when you unpack the assets, you're going to find the PNG and you will find basically single sprites here. So we're going to use those for now, but later we're actually going to use sprite sheet. And we're going to learn how to parse this XML file to actually load the sprite sheet, but that's for another time. All right. With that said, I actually want to refactor some stuff because it's just going to be easier to work. And actually, let's do that here. Maybe I should enlarge this guy because this is just refactoring part. Here, if you remember, below we had this const render, and render draw. But actually, since we're going to be working a bit with async and await, I would like to refactor the constructor and just pull everything from the constructor here. So everything that's in constructor, just got it. And there we're going to actually create our public async initialize method and just let's paste everything here. All right, that's first part. And so that it works, now we actually have to do this because it's async. We actually need to wait for the initialize, but since we cannot wait in non-async method, we actually can do this. And then here, so we can call initialize, then, and when it's resolved, we actually call draw method. And that generally should work. We just have to fix those if TypeScript is complaining. But let's see. Let's see. Okay, there. It's working. Okay, all right. Perfect. So back to our. Actually, I can use it like this. Okay, back to our code. Further, I want to actually refactor texture, and I'm going to explain it to why in a bit, but actually let's start with it. And let's just create our texture file. And here we're going to export class texture. And here we'll have constructor public texture, which is of type WebGL texture. Then we're going to have width and height. And the public here, if you're wondering what this is, it's just kind of syntactic sugar. So we could say public texture WebGL texture, and they say this texture equals texture, but then we cannot use the public here. So if I add public, this is done automatically for us. So it's a bit of syntactic sugar of TypeScript. All right, this is fine. Let's just remove this. And then previously in main TS, let's close this. We had this load texture. We're going to rip that off from here. Just I need to be careful about it. All right, cut it. And then let's go to our texture. Paste it here. The GL is actually now going to be parameter that we get in rendering context, and then let's just refactor this this GL. We can press Control F or Command F on Mac, and then let's just say replace this GL with just a GL. Alright, that's solved. We're actually going to return the texture. So now let's first make it public, static, async, and we're actually going to return promise the texture. Alright, let's see now. We can get rid of this bind and this, because we're actually going to always await for image to resolve. And here we're actually going to rip this off and put it in on load. And here let's just create a promise. Texture, resolve, and then at the end we can just place this and return promise. So also remove this here. So our code that creates the image now needs to be inside of promise. And what promise is, if you're not familiar with TypeScript, it's just essentially something that gets resolved at some later point. So when we call resolve, our promise is actually going to be resolved, and the async method is then done. So it will actually await for this code to load asynchronously, and then it will be resolved. Essentially, then the return will be not hit, but actually the code is going to continue after we call resolve. So we need to call resolve somewhere here, but our resolve will have parameter, and that's our texture. So we're returning new texture or this class. Returning texture, then image width, image height, and that should be it. Let's just move this actually to here, and then let's just have error handler as well. If something goes wrong, we can say reject, but we can also console error failed to load the image. So just in case, so that you know. All right, or we can even say alert here. Maybe something is wrong. We can say const message is equal to this, and then we can write in console, but we can also pop up alert with message. All right, so let's change our texture now, which is here, to actually load the game asset. So further, I would like to create something called content, not a new folder, new file. Let's just call it content. TS, and this is essentially just a small class which will hold all our game content, assets, textures, etc. So we can just say public player texture. It's not WebGL texture, it's this texture object that we have created, and then we can have public static async initialize. It's actually not returning the promise content. That's wrong suggestion. It doesn't have return type. We can just say player, this player texture. Actually, it needs to be static here. Is await, and we also need to pass GL context here. And here it's assets, PNG, and then I can use one of these. Let's say player ship orange. That will be the one that we're going to use. So let's just go to our main again, and actually that's fine. Let's just see. Actually, let's refactor render as well. We're going to have separate class for it, renderer, and here just going to pull everything about this. So main is just going to initialize our renderer, So let's just pull everything from here to render. Sorry, I also need to pull these imports into render as well. And then in the main, we just need to, okay, actually, my bad, I need to export this class so that we can export it to other files. And then here, I can just say import renderer from renderer. Also, we need here it's fine, so we don't have this texture anymore. Our texture is actually going to be texture, but we don't need it like this anymore. We can just say we can remove this, and somewhere over here, as soon as we have the GL context, we can say content, initialize this GL, but we need to await it. Make sure to await it, otherwise your call it will break otherwise. And then somewhere over here in draw method, it should work automatically because our texture is already bound, but let's just do it. Let's just bind it. And then we can say, yeah, this is fine. So our texture is bound now. So let's see, what do we get? This should work generally, but it doesn't for some reason, which is interesting. Failed to load image. Okay, good that I have added warning because I probably made some small error here in content. Let's just see. Playership orange. It must be something else. It's in PNG. Playership 1. So I'm just missing 1 here. And now it works. All right, perfect. So that's it. You will see this white background, and actually we're going to deal with this in next video because this video is going to be probably long as it is, but it's not something that's not going to be fixable. So now I actually want to discuss orthographic projection, and for the orthographic projection we're actually going to use GL matrix. As I opened it here. So basically the GL matrix is just a library. It's a TypeScript library that will provide us with all the matrices and vectors that we're going to need for our math. Since I didn't want to write library from scratch, that would take way too much time, and it's not really a focus of this video. So you can open a new terminal here and just run npm install GL matrix, and then we can save dev so that it's saved to our dependencies of our file. You should find it. And now we should have it, if you did everything correct, it should be here, the GL matrix 3.4.3. And now let's just close assets. I don't want it's all right. Anyway, sorry. And now we're just going to create our camera class, and let's start coding our camera class. So here, what we're actually going to need is to use that GL matrix, and that we can do simply by saying import matrix 4 from GL matrix, and then we can have our export class camera. And first I'm going to define the matrices, then I'm going to try to explain it. We're going to have projection matrix, so this is important, and then we're going to have view matrix. So what are projection and what is view matrix? Basically, view matrix, if we take a look at some of the arguments here, let's just have our update method. So we're going to have update method, and here we're actually going to create projection matrix, but let's first create a view matrix. This view is matrix 4, look at, and then here we have some arguments. As you can see, we need to provide matrix. You can just do matrix for create. Then there is I argument, center argument, and up argument. So what are those? Well, basically it kind of explains it if you look at the documentation. Generally look at matrix with given I position, focal point, and up axis. So essentially it means if you imagine our camera, let's say that we have our scene, and there is somewhere cameraman over here, and basically with this argument you can say where is he looking at, and what is the up, like up position. So up is y, so that's why it's 1, so it will always be just 1, so it's very common, but so let's use that. He's looking somewhere in the z direction, so if we have, for example, here we have y, then we have x, and then here going to that direction, like looking into the screen, it might be z, and then we just say, okay, look at z, or minus z, for example. And here, it's just position. He's at 0, 0, 0. All right. But actually I wanted to use 0, 0, 1 here. And here we're looking at 0, 0, 0. That's fine. And now we have defined our view. So basically view says, where am I in the world, and where I'm looking at, and what would be my up coordinate, so that I just know how to orient myself. And here we're actually going to have orthographic projections, but for that we're just going to have the constructor. We already know this sugar syntactic sugar, so we're going to have width, and then we're going to have height, and we're not going to call this update. We're going to get back to it, but now let's define our projection matrix, and this is all wrong. So here it's matrix 4 create once again, but arguments are a bit different, so we're going to pass 0, and then this width, and then this height, 0 again, -1 and 1. So for orthographic projection, or if you have perspective projection, what it defines? So we had this idea of a man here looking somewhere, right? If he has a camera, or let's take, let's consider how does the world look like for him. So in your game you might have 2D perspective, or you might have 3D perspective. So 3D perspective is done via perspective camera, and 2D, what we're concerned with, is done with basically orthographic camera. And for orthographic camera, we just provide some arguments, but basically we say, okay, where our world begins, where it ends, in both x and y, and then the last two arguments, if you see here, are just -1 and 1. So basically that defines z. So if our z is below -1 or above -1, it's not going to be visible in our scene. So that's kind of how it works. So basically view matrix define where we are at the world, and the orthographic, or sorry, projection matrix define how our world will look like that. But the important takeaway here is, if you remember, like I mentioned, in WebGL we have this screen, and it goes from -1 to 1, 1, -1. But we can like think about matrices in a different way, right? So what this does is, if we, for example, have a sprite, but we want to define it to be at 0, 0 position, and have a width of 100, or let's say that we want our right corner to say that it ends at 100 and 0, and our lower corner at 100 and 100, x, y. So what does this solve, this matrix solves? Well, essentially it can map this rectangle here to our world so that it fits into -1 to 1 position. So essentially it's like a mapping. How do we map from one coordinate system to another? And our system that we want to map to is our WebGL, because WebGL really knows only geometry that's in these coordinates, right? -1 to 1. And that's where our matrix is used to. So when we multiply by some matrix, we actually want to map that to -1 to 1 space. So you can also think about matrix like that. And so further, we're actually just going to have our public. And this is what we're going to pass to shader. It's going to be projection, view matrix, and it's of type matrix 4. And here we can just initialize it to basically identity matrix. And here our projection matrix moment is just going to be projection times view. So, and then we get projection view matrix. All right. Now we have to tackle uniforms in our shader, and we actually need to paste that matrix to a shader. So how do we use it? Well, basically our uniform is some global variable in our shader, and we can call it projection. We can call it projection view matrix. And here we can just multiply our vertex times projection view matrix. And what it does is, like I mentioned, let's just clear it once again. So basically, we will have maybe some rectangle that's going to be let's say here 0 0, but here it might be 100 100. So we solve this issue by our projection view matrix, and we can actually map that into this space so that it makes sense, right? It might be somewhere over here. And that's what our projection view matrix is going to do. So it's essentially going to map that. We're going to have not, so yeah, we don't have to think about this as -1. We can actually think about this as 0 to 800 and 0 to 600 here instead of -1 and 1. So that's what our matrix is going to do. And so now we have that. And where is my game? Here we have loaded this. So let's actually do our matrix stuff. And for that, we're going to go to renderer. We're going to import our camera. So we can just say camera from camera. And actually, we're going to touch this later a bit, but let's just say we have created our camera. All right. So we can just create instance of it. We're going to need the global variable. Camera. All right. And here, it's just going to be off size of the canvas, so that's fine. And further, once we have our program, we actually need to call something, and that's, I'm going to explain it in a second, but we're going to have something projection view matrix, not this, location, and that's going to be of type WebGL uniform location. So this is important. You're going to see in a second why, but we actually have to query for this location. So we can say this projection view location is this. I need to enlarge this. So we have to say GL, get uniform location. We have to pass our program. As you remember, our program holds our shaders, so it knows of vertex and fragment shader. And here, this thing needs to correspond with what we have in our shader, and then we can actually use this. So we can pass data from the CPU to the GPU via this, and this is essentially our address in shader, this uniform location. Okay, and finally, to actually use it, somewhere over here, as you remember, we had camera update, so we can do this here, this camera update, and then we can pass it to our shader via this not GL use program, actually just use it's called uniform matrix, and you want this signature, so for float vector, and then you can just pass this location. We don't want to normalize anything, and then just the value that you're passing to a shader. And if I save it, interestingly, nothing happens because I probably haven't used this projection view matrix. Or rather, I have used it. This is interesting. Okay, sorry. I forgot. I restarted this, so it's not at 5174. It's actually here. So this isn't working, and there is a reason why it's not working. It's actually really simple, because as I mentioned, in our render, we have this space. So it's probably somewhere over here, just the size of 1 pixel. As you remember, now our space is different. And how can we fix that? Well, let's just fix our coordinates so that they'll look easier to look at. Let's just place left bottom at the top. Then what am I going to define? Let me think here, because this will be a bit important later on. We can just say our right bottom corner. Let's stay as it is. Actually, let's use our right top. Let's go left, right, then right bottom, and then wrap back to left bottom. Okay, and here we actually need to fix this as well. Now, so it will be 0. Then we want to go to right top, for example. That's 1. And then we can wrap to left bottom, so it will be 3 here. The other one can go from right top, so 1, to right bottom 2, and then 3 to left bottom. Okay, but here we're actually going to have this idea of x being, let's say, 0 or 100, even better. Y being 100, and then we're going to have something called width. It can be also 100, and height, it can be also 100. And here we're actually going to pass positions. So for our left top will be x, this will be y. Right top will be x plus width. Right top will be just, it will be y. No, sorry, it will be exactly y. Right bottom in y direction is y plus height. This is x plus width. This is x, and this is y plus height. Yeah, okay, you can see it here perfectly, but let's just enlarge it a bit. So we can say width and height is 200. Perfect. So what did we do here? So just to explain it real quickly, let's get rid of this. So basically what we have created here is our coordinate system that goes from 0 to 800 and then 0 to 600 in this direction. But here we said this is our left top. So we here specify our position, because our origin of this rectangle always will be top left corner. So we have 100 here, 100 here. Here it's actually 100 plus width, and this width is 200. So it's 300 for this corner and 100 for y, because we're just staying here. And then similar to this, we have also 100 here, and then 100 plus 200 for our height. So 300, you get the idea. But important thing is, so you can now work with this kind of coordinates where if you specify 0, 0, if you see our top left corner will be here, right? Because this is our origin, 0. So you can play with it if you just move it 10. So we will move 10 pixels to the right. Perfect. You probably get the idea. So this is the coordinate system that we're going to use from now on. With that said, let's just create a new class, which will be rect ts, and our rect class is just going to, we need to export it, class rect, and it's going to be a really simple class. We're just going to have our constructor, public x for position, number public y for y position, and then width and height of the rect, and that's everything with the rect. So we can use our rect here. Okay, and here now what we actually need to do is to create some method that will draw our sprites so that we can have multiple sprites here. And for that, this buffer needs to be global variable. So we're going to have here buffer. We're going to be refactoring part by part because there is a plenty of stuff that we're going to need to do. And actually, we don't even have to care about this anymore. We can just pass the number of elements. So we have 7 here times 4, 7 times 4. We can just specify here 7 times 4. And we can rip this. Actually, we can discard this. For now, we're going to deal with this later, but we will say here this buffer. Let's see further. Let's use this program, and actually we need to leave it here, but we need to copy it, and then let's just place it here. So we'll have our bind texture, uniform, draw elements. And the reason why I replace this buffer is probably because we're going to have a separate method which is going to be called draw sprite. That's our name for our method. So it will take texture and then it's going to take rect. And here we're actually going to copy all of this. We're just going to leave this. And here now we will be able to call this draw sprite player, and then we can just pass it some parameters. Let's say that our player will be 100, 100, and maybe the width will be 200, 200. So nothing yet, because we actually need to, if you remember, now our buffer is basically empty. We just specify the size of our buffer, but we still need to fill it with data, and actually we're going to do that. And we're going to have private data floated to array. And here we can actually move this 7 times 4 instead of there. Instead of here, we can just say this data, so that it knows the size. So that it knows the size of the buffer. And actually we're going to use data here. And now bear with me. So now what we're going to do is actually fill the data here and then pass it to the GPU. So we can say this data, this will be our top left. So we had X, we had Y. Here the texture coordinates were 0 and 1 actually. So let's just fill this in quickly. X, Y, U, V. And for our colors, we just had 1, 1, and 1. Then we had top right. So that was position X plus width of that rectangle. Position Y, coordinates are 1, 1, I believe. No, I think there should be 0, 0 for top right. Anyway, if something is wrong, we're just going to fix it. It's not a big deal. We can always fix it at the end. Let's just finish it. So bottom right will be rectext. That's fine. That's fine. So bottom left is just an X and then height of a rectangle. And finally, we now specified our data. So we will be changing this data whenever we need to draw a sprite. And here we can say actually bind buffer. We're going to bind the data. And then in WebGL, we have this called buffer subdata, which is going to fill our buffer with data that we have provided it. So it will fill it with this, and then you can see that we also have image here, but something is wrong because it's it should be upwards. So let me just check this quickly. Top right. Have I missed something somewhere? Let me see in my notes. Maybe I should just change directions here. So let's do this. and then let's see what we get. Nothing interesting. And here, here. So let me just think first. All right, solved it. Here we should have 0, 1, 3, and then 1, 2, 3. And here, so take a look at these. So make sure to write them right. Also these, top right. Also these. And these guys. So the colors are not important, they're just here. If, for example, I change this, our color will have some shades of blue, but that's not important. That's something that we're going to use in future for right. Now it's not important. What's important is this. And then since we have that, we can also say here we had, like say we can do this now. This should work. Let's move this guy to 300 and maybe here to 300. If I save, you can see now we have multiple images. With that said, we can also add different kind of. So for example, we could have here public static UFO blue, I believe that I used. And you can check it here. It's called, yeah, exactly, it's UFO blue. So we can just copy here. Or we can say here UFO blue. And we can say here UFO blue. So you'll see how easy it is with this refactoring to add new stuff. We can just specify it here, and then we can use, instead of this here, we can use UFO blue and here as well. And it doesn't work because interestingly enough, I might have forgotten something. Let's just see. So I bind the texture here. I call use program. And then I have draw elements, BindBuffer. If blue, we would have gotten warning if something was wrong here. If it's first one. Interestingly enough, it doesn't work. Okay, found the bug. It's actually here because I used here content player texture instead of texture that we're passing in. So now it kind of works, but we still have to pass maybe player here. Let's say this will be our player. And if you look at the player, you're going to maybe notice that the coordinates, sorry, the size is 99 times 75. So you can use that instead, just because it will look correct. Okay, here. All right, that's it. We can leave here, and for the next time we're actually going to be dealing with this kind of white background. It's got everything to do with alpha blending, so we're going to be discussing that a bit, and we're probably going to optimize this a bit as well in further videos. And I will show reason why the next video, because this is very unoptimized code, and it's really kind of bad. Beside that, I think that we're good. We can stop here, and hopefully you enjoyed this video, and then until next time.